So now we're just going to do a quick few examples of how to actually solve inequalities. So I'm going to read through this question first. 3x plus 7 is greater than or equal to x plus 2. X is an element of z. So that just means x is an integer. An integer is a positive or negative whole number. So your number has to be whole. It can't be a decimal. It can't be a fraction. And then it says plot your solution. Now that can be a bit confusing. That's sometimes it, but so I'll show you at the end, and it'll make it a bit easier. Now back to the question itself. This is essentially an algebra question. Now the main aim for all algebra questions, the way I always explain it, is if you can get your letters on the left hand side and the numbers on the right, that's the main aim of how to isolate the x and get it and so on. So again, the first steps that we'd always try and do, get all of the letters over to one side. 3x is here, that's positive, that's okay. That x needs to go over, and when it crosses over, it changes signs. So 3x minus x is greater than or equal to. That 2 stays where it is because we want the numbers on that side. 7 comes across and becomes minus 7. Clean up another bit. 3x, take 1x is 2x. Greater than or equal to minus 5. Now you can tell that nothing, the sign itself in the middle, the inequality hasn't changed because all I've done is add or subtracted positive or negative numbers. So adding or subtracting doesn't change anything. It doesn't change the sign. Now 2x is greater than or equal to minus 5. We don't want 2x, we want x on its own, so we need to divide this side by 2. Now if you saw my last video, you'll realise that if you divide by a positive or negative, if you multiply or divide by a positive number, it doesn't change the inequality in the middle, so it doesn't change it in this case either. X equals minus 5 over 2. Greater than or equal to. So that doesn't change in the middle because we've only divided by a positive whole number. So it doesn't make much of a difference. Now, the next bit is the important bit. This is where a lot of marks are lost. You can see from the solution that we just worked out a second ago that x is greater than or equal to minus 5 over 2. Now, if you use your calculator, that is the same as minus 2.5. I'm going to put a small dot just to show where that would be on the number line. Minus 2.5 is roughly there. Now I'm not going to put it in fully at the minute. I just put a little notch there so you can see what it is. But we have to go back to our original question, and it says x is an element of z, so it's an integer. And as I pointed out, integers are the whole numbers, positive and negative. Now this isn't a whole number, but minus 2 and minus 3 are. Now it's up to us to decide, right, what does this mean? This means that x is bigger than or equal to minus 2.5. So what's the first integer that is bigger than minus 2.5? It's this one, minus 2. But minus 1 is also bigger than it. And 0, and 1, and 2, and 3, and 4. And so on. It keeps going and going and going. So our solution set is these dots. Okay, it's not coloured in. You'll see that in a second. There's one or two where you have to actually colour in the number line. But in this case you don't, because it's an integer. It's only the positive and negative whole numbers. You don't count the fractions. So this is our first answer. Minus 1, 0, 1, 2, 3, 4, and so on up the line. Now this example is a little more complicated. It says solve 1 over 6 multiplied by x minus 1 is greater than or equal to 1 over 3 multiplied by x minus 4. And this little bit at the end is important as well. X is an element of r, so that's the real number, so that's every number we can think of. Now, anytime you go through a question, usually the most complicated part, or what makes it most awkward, is the fraction. So what I'm going to try and do straight away is to get rid of these two fractions. Now, because that's 1/6 and that's 1/3, I could multiply by 3 to get rid of this one, and could multiply by 6 to get rid of that one, and we'd be okay. But 6 and 3 are actually common numbers. So 3 is a factor of 6, 6 is a multiple of 3. So if I multiply by 6, it will get rid of this 6, and it will get rid of that 3 at the same time. So I'm going to multiply both sides by 6. 6 multiplied by 1 over 6 by x minus 1 greater than or equal to 6 by 1 over 3 by x minus 4. That 6 will cancel with that 6 as normal. 6 1/6 is 1, so that's okay. This 3 will cancel with one of those 3's, leaving a 2 above. Basic enough. So now we have x minus 1 is greater than or equal to 2 times x minus 4. Now we can work it out as normal. X minus 1 is greater than or equal to 2x minus 8. Again, letters to the left, numbers to the right. X minus 2x is greater than or equal to minus 8 plus 1. X take away 2x is minus x, greater than or equal to minus 8 plus 1 is minus 7. Now, at the minute, we have minus 7 is greater than or equal to minus x is greater than or equal to minus 7. We don't want that. We want a positive x. So how do you change the sign of an x or anything? How do you change the sign of anything? It is multiply by minus 1. Now, if you remember back to the solution or the last video, when you multiply or divide by a negative number, the inequality in the middle changes sides. So x becomes x, minus 1 by 7 becomes 7, but this inequality in the middle changes, it flips over. And now that is our solution. X is less than or equal to 7. Now we need to plot that on the number line in the next little section. So now when we're plotting our points for the last section, what we need to be very careful of is what it says up here. X is an element of R, so that means it's all the numbers. It's not just the whole numbers, it's not just the positive or negative integers, it is every single number you think of. So if we look at our solution set down here, we have x is less than or equal to 7, so we start at 7. Now what I'm going to do is put a circle around that, because that's our point. Because it says equal to 7, I can colour that in, because 7 is included. If there was no equals, I would just put a circle around it and leave it blank. Now, x is less than 7, so it's all the numbers this way, and it's the real numbers, so there's no cut-off point. It doesn't stop at 0, it's not just the integers, and it is all the numbers in between. So what I do is just take my pen and just shade all of the numbers. And that is enough to show that you know exactly what you're talking about. If you colour in the line, it shows, yep, it's from here the whole way back, and it keeps going and going and going forever. Okay.